So picture this. You're an executive, right? And you've got, I don't know, maybe 2 minutes before a massive board meeting.
Well, the pressure's already on.
Exactly. And you ask your AI to summarize this 50-page customer crisis report. It instantly hands you 3 beautiful, crisp bullet points. You read them, you feel totally prepared.
But then there's that feeling.
Right. In the back of your mind, this tiny creeping voice is just whispering, wait, did it leave out the most important part? Or, worse, did it just completely make that up?
Yeah, it is a very specific, very modern kind of anxiety.
Yeah.
Because, you're staring at this perfectly formatted output, but you are fundamentally questioning reality just a little bit.
Because you have no idea how it got there.
Exactly. You just don't know the mechanics of how it was actually generated. It's a black box.
And well, for you or me individually, maybe that anxiety is manageable, right? We can double check the source, we fix a little error, and we move on.
Right. The stakes are low.
But consider what happens when you scale that up. Like getting an AI to summarize a meeting or research notes for an entire enterprise.
That is a whole different ballgame.
It really is. If you're running a customer support team handling, say, tens of thousands of tickets a day, one bad hallucination doesn't just cause a mild inconvenience. It breaks all trust in the system.
Oh, absolutely. Because at the enterprise level, the stakes shift entirely. It goes from personal productivity to, quite frankly, organizational liability.
Which is terrifying.
It is. You can't just deploy a summarization tool, cross your fingers, and hope it tells the truth.
But wait, so if a single bad summary can cause that much chaos at the enterprise level, how do you actually fix it? Because you can't just give an AI a thumbs down and hope it learns its lesson.
No, that doesn't work at all.
Right. You have to break down what makes a summary, quote unquote, good in the first place. And that is the exact mission of today's deep dive.
It's a really good one, too.
It is. We are looking at a truly fascinating engineering blog post from SupportLogic. This was published in March 2026, and it's titled, Bringing Measurable Confidence to GenAI Summarization.
That word, measurable, is key there.
Totally. We're going on a full technical deep dive into how enterprise companies are actually taking generative AI from this unpredictable magic trick, right, to a highly measurable, production-ready system.
And to solve that trust issue you were just talking about, SupportLogic realized they had to, fundamentally change how AI is evaluated.
Because the old way wasn't working.
Right. The industry standard has mostly been grading AI summaries with a simple pass or fail.
Yeah.
But summarization quality, it absolutely cannot be reduced to a single score like that.
Because, well, a summary might be incredibly concise, it might read perfectly, but it could entirely miss the actual point of the underlying document.
Exactly. Or, maybe it hits all the major themes, but it's just full of absolute lies.
Which is the worst case scenario.
Yeah.
So the framework measures summary quality across 6 very specific dimensions simultaneously, right?
Yeah, 6 dimensions. It's really about creating this holistic mathematical picture of the system's performance.
Okay, so let's dissect the anatomy of a perfect summary here. I'm looking at this framework, and the first dimension they measure is faithfulness.
Yep, faithfulness.
And then the second is hallucination risk. Okay, wait, I have to pause here.
Sure.
Aren't faithfulness and hallucination risk basically the exact same thing? If it's not faithful, it's hallucinating, right?
I know, they sound identical on the surface, but they actually measure very distinct types of mechanical failure in the AI.
Okay, how so?
So faithfulness is about distortion. It's taking facts that are actually present in the source text and twisting them.
Ah, okay.
For example, if the original transcript says the customer was mildly frustrated, and the AI summary says the customer was enraged and threatening a lawsuit.
Yikes.
Okay. The core entity, the customer's mood, it was there in the data, but the AI warped it.
Oh, I see. It's like taking real ingredients, but baking a terrible, toxic cake.
That is a great way to put it. Now, hallucination, on the other hand, is entirely inventing new information that was never there to begin with.
So no ingredients at all?
None. If the source text is just a routine transcript about a password reset, right? And the AI summary suddenly includes a bullet point saying, oh, a full refund of $500 was issued.
Oh, wow.
Yeah, there were no ingredients for that.
Right.
The AI simply manifested a refund out of thin air. And both of these errors destroy trust, obviously, but they require entirely different prompting strategies to detect and mitigate.
Okay, that distinction makes a lot of sense, actually. So we have faithfulness and hallucination risk. What are the other dimensions rounding out this rubric?
Well, you also have instruction adherence. Basically, did the AI actually follow the strict formatting and prompt rules you gave it?
Like using bullet points if you asked for bullet points.
Exactly. Then there was topic coverage. Did it capture all the important themes, or did it, hyper-focus on one minor detail and completely ignore the rest?
Right.
We also look at clarity and conciseness. Just, is it readable? Is it structured efficiently? And finally, there's a dimension called persona usability.
Persona usability. Okay, how does an AI know if something is usable for a specific person?
You really have to think about the end user here. A summary generated for an operations executive who is just looking at high-level weekly trends, well, that needs to look vastly different than a summary generated for a frontline support manager.
Because the manager needs the details.
Right, they need to understand the granular step-by-step history of a specific customer escalation. So persona usability just asks, is this output actually formatted and tailored for its intended audience?
Okay, so we have these 6 complex dimensions, but here's the massive roadblock that's kind of staring us in the face.
What's that?
Well, if you are an enterprise processing hundreds of thousands of summaries every single day, how do you actually score them across these 6 criteria? I mean, you clearly can't hire an army of human graders to just sit in a cubicle reading summaries against source texts all day long.
No, absolutely not. Manual grading is a total non-starter at that scale.
Yeah.
It's too slow, the cost is astronomical, and frankly, humans are incredibly subjective.
Oh, for sure.
If you and I read the same 50-page report and its summary, our judgments on clarity or topic coverage might vary wildly. It literally might depend on our mood or how much coffee we've had that morning.
That is so true, which means we enter the world of robots grading robots.
Yes, and this is the cornerstone of the SupportLogic framework. They use what are called judge LLMs.
Judge LLMs.
Yeah, they deploy specialized automated language models for the full purpose of evaluating the outputs produced by their main summarization agent.
Wait, I really want to understand the mechanics of this. How does an AI actually judge another AI? Because I imagine you don't just feed the summary into a prompt and say, hey, is this good?
Oh, definitely not. You have to treat the judge LLM like a highly logical auditor. You give the judge the original source content, the generated summary, and a very structured mathematical set of evaluation instructions.
Based on those 6 dimensions we talked about.
Exactly. You literally prompt it to say, extract all factual claims from document A, extract all factual claims from document B. Map them against each other.
Wow, that is specific.
It has to be. And then it says, if document B contains a claim not found in document A, deduct a specific number of penalty points.
So it's essentially having a senior editor review a junior writer's draft, but with incredibly strict parameters.
That's a perfect analogy.
Like the junior AI is incredibly fast, but maybe a bit reckless, right? Just writing a whole article in 3 seconds. But it doesn't go live until the senior editor AI reviews it.
Right.
And the senior editor isn't just eyeballing it. They're sitting there with a red pen and 6 different clipboards scoring it 1 to 10 on each specific metric.
And just like a human senior editor wouldn't treat a minor spelling mistake with the same severity as, say, outright libel, this automated system doesn't treat all 6 dimensions equally either.
Oh, interesting.
Yeah, the scores from those 6 clipboards are aggregated into a single composite confidence score. But that score is heavily weighted.
Well, because a summary being a little unpolished is annoying, but a summary lying to you about a $500 refund is catastrophic.
Exactly. Factual faithfulness and hallucination detection carry significantly more weight in that composite score than simple clarity.
That makes a ton of sense.
The ultimate goal here is to evaluate these outputs with hard, quantifiable quality signals. It transforms what is normally an unpredictable output into a mathematical reflection of reliability.
And having this quantifiable confidence score leads to something really powerful for the engineers who are actually building these systems, because it allows them to take prompt engineering out of the realm of dark magic.
Yes, it shifts the entire discipline from an art to a hard science.
Let's be honest, for most of us, prompt engineering feels like a bizarre ritual. You're sitting there adding the word please or typing take a deep breath and think step by step in all caps.
Yeah, well, hoping it helps.
And you're just squinting at the screen trying to guess if the AI is behaving better.
And, that trial and error approach might work fine for writing a quick email, but it's terrifying at an enterprise scale.
Oh, yeah.
So SupportLogic uses their confidence score to turn prompt engineering into an iterative optimization loop, and it's based entirely on quantitative evidence.
Okay, I'm stuck on something here, though. I want to push back a little on this idea of prompt tuning at scale.
Go for it.
You're telling me that changing a few words in an instruction, like asking for a bulleted list first or defining the persona slightly differently, that is somehow moving the needle enough to justify building this massive automated testing infrastructure.
It does, and the math behind it is staggering when you look at enterprise volume.
Really?
Yeah, because at an individual scale, sure, a tiny prompt tweak is mostly invisible. But let's say an engineer tweaks a prompt, runs it through the Judge LLM pipeline, and the data shows it drops the hallucination rate by just 2 percentage points.
Just 2%.
It's 2%. But if your company processes 100,000 support tickets a month, you just prevented 2,000 fabricated summaries from reaching your staff.
Wow. 2,000 lies caught before they happen. That really puts it in perspective.
Right. That translates to hundreds of saved customer relationships, a massive reduction in managerial escalations, and just undeniable time savings across the board.
Okay, I'm sold.
And furthermore, having this quantitative evidence tells engineering leaders when a prompt fix is actually sufficient versus when they have hit the absolute ceiling of what a specific AI model can do.
Which means they know exactly when it's time to pay for a much more expensive, upgraded model.
Exactly.
And that brings us to the really fun part of this deep dive. Because what happens when you take all the major LLMs currently on the market and force them to run this exact same six-dimension gauntlet?
It gets really interesting.
The SupportLogic Engineering Team did exactly this. They ran a massive model benchmarking bake-off. And the data here really strips away all the marketing hype to show us what these tools can actually do.
The results are highly illuminating, especially because they applied them to a rigorous evaluation data set made of real-world support transcripts.
So let's look at the data. Out of all the models tested, the #1 overall winner, meaning it ranked highest across that weighted composite confidence score, was Anthropic's Claude 4 Sonnet.
Yeah, and what stands out in the benchmark isn't merely that it won, but the consistency of its performance.
The consistency.
Right. Claude 4 Sonnet exhibited a median faithfulness of 100%, with a standard deviation of just 15.5%.
Okay, let's clarify that for a second. Standard deviation in this context. Why should the listener care about that 15.5% number?
Well, standard deviation measures the spread with the volatility of the results, right?
Right.
If a model has a high average score but a massive standard deviation, it means it swings wildly. Sometimes it's a genius, and sometimes it's a pathological liar.
Like a really smart but chaotic employee.
Exactly. So a low standard deviation like 15.5% means Claude 4 Sonnet doesn't just score well on average, it performs reliably across almost every single prompt you throw at it.
Wow.
Add in a 95.5% topic coverage rate and a low 7.5% mean hallucination rate, and you have a very stable system.
So when you need the AI to cover all the bases consistently without making things up, Claude 4 Sonnet is the clear choice here. It seems ideal for high-stakes tasks like, generating an executive briefing on a major customer crisis.
Absolutely. It provides the reliability profile that enterprise executives actually demand.
But if we dig a little deeper into the data, Claude 4 Sonnet wasn't the absolute king of the facts. That specific title goes to Google's Gemini 1.5 Pro.
Yeah, Gemini did really well there.
It achieved the highest raw faithfulness score at 94.1%. And get this, the absolute lowest hallucination rate of the entire group, just 4.3%.
That is incredibly low.
Right. So if factual precision is your absolute top priority, like no hallucinations allowed whatsoever, Gemini 1.5 Pro is the winner.
It is, though the benchmark does note an important caveat regarding cost.
There's always a catch.
Always. Gemini 1.5 Pro comes with a higher per token cost if your prompts go above 128,000 tokens.
Okay, for context, a token is basically a piece of a word. So 128,000 tokens is massive. It's roughly the length of a 300-page manual.
It's a lot of text.
If you're feeding the AI an entire library of a customer's history just to summarize their current issue, that's when Gemini gets incredibly pricey.
Exactly. It's a critical trade-off between architectural capability and operational expense.
Now, we have to talk about the danger zone. The models that, according to this specific rigorous benchmark anyway, struggled significantly with reality. We are looking at OpenAI's GPT-4o Mini and Meta's Llama 3.18b.
The hallucination rates here are really the defining metrics.
They are eye-opening. GPT-4o Mini had a hallucination rate of 13.8%. And Llama 3.18b had a whopping 20.0% hallucination rate.
20%. I really want you to picture what that actually looks like on the ground.
It sounds bad.
It's terrible. Imagine it's Tuesday morning. Your call center agents open up their dashboards to review 1,000 customer summaries. With a 20% hallucination rate, 200 of those summaries contain a fabricated detail.
Oh my God.
Yeah. An agent reads the summary and tells the customer, "Oh, I see we promised you a free replacement yesterday," when absolutely no such promise was made.
That is a nightmare.
The resulting chaos destroys trust instantly. It essentially renders the tool a liability rather than an asset.
It becomes a coin flip of anxiety at that point. Just to round out the field, they also tested Claude 3.7 Sonnet, which sat in the middle with a 12.1% hallucination rate, and Gemini 2 Flash at 9.6%. But looking at this leaderboard, a question naturally arises. If Claude 4 Sonnet and Gemini 1.5 Pro are so vastly superior when it comes to quality and hallucination control, why doesn't a company just use them for everything? Like, just ban the weaker models entirely?
Because in the real world, engineering is inextricably linked to basic economics.
The cost curve. And the price disparity revealed in this data is honestly staggering. Let's look at the average cost per 100 support cases. Running those summaries through the highly efficient lower-tier models like Gemini 2 Flash or GPT-4o Mini costs literally pennies.
Pennies.
We are talking about 22 to 27 cents to summarize 100 cases.
The compute cost is remarkably low for those.
But running those same 100 cases through the reigning champion, Claude 4 Sonnet, costs $6.67.
And you have to multiply that difference across millions of daily transactions.
Mm-hmm.
When you do that, you're looking at an exponential leap in operational expenditure.
It's like vehicle routing for logistics, right?
Yeah.
You don't use a massive, heavily guarded armored truck to deliver a single pepperoni pizza.
No, that would be ridiculous.
And conversely, you don't use a bicycle with a little wicker basket to transport gold bars across the city.
Right.
You use the right vehicle for the right level of risk.
Exactly. And SupportLogic recognized this, which is why they don't rely on just one model. They utilize what they call an AI orchestration engine.
An orchestration engine?
Yeah, this engine dynamically routes the summarization task to the appropriate model based on specific parameters like task type, volume, and quality requirements.
Let's map that out. If you have a massive volume of low-risk workflows, maybe you're just categorizing general inquiries about store hours where a slight categorization error isn't going to sink the company, the orchestration engine sends that to the 22-cent models.
Exactly. The cheap models handle the baseline load.
Right.
But the moment a high-stakes customer escalation comes in, say a critical data privacy issue that a human manager needs to review and act on immediately, the routing engine identifies the risk.
And it reroutes it.
It automatically kicks that task over to Claude 4 Sonnet. It spends the $6.67 because the business risk of an error in that specific context is far more expensive than the compute cost.
This is such a crucial takeaway for you listening, regardless of what field you're applying AI to. Building a real production-ready AI system isn't about running endless bake-offs to crown the one perfect model.
No, not at all.
It's about orchestrating a team of models based on a deep mathematical understanding of your cost-to-quality ratio.
It really signals a profound shift in the maturity of generative AI. We are moving well past the novelty phase of chatbots. The true strength of generative AI in an enterprise setting isn't just the raw ability of a model to output text.
Right.
It is the invisible infrastructure built around it.
It's the multidimensional metrics. It's the judge LLMs acting as automated senior editors with their red pens and clipboards.
Oh.
It's the prompt tuning loops powered by quantitative data, and the orchestration engines dynamically balancing risk and cost in real time.
All of that working together.
That invisible infrastructure is exactly what allows us to trust and deploy AI confidently.
Because without that invisible infrastructure, you are just blindly hoping the machine doesn't hallucinate a disaster. With it, you are engineering measurable confidence.
Which brings us to a really fascinating question. We've spent this whole deep dive exploring how systems use judge LLMs because manual human review is simply too slow, too expensive, and far too subjective.
Right.
Which begs a provocative thought for you to ponder long after we wrap up here. As these automated judge LLMs get more and more rigorous, as they become capable of holding thousands of complex mathematical criteria in their minds simultaneously, are we rapidly approaching a point where human oversight actually introduces more error into the evaluation process than the AI does?
It's a wild thought.
At what point does human intuition simply become the bottleneck to quality?
It is a challenging thought, especially considering how much we instinctively rely on human validation to feel safe with machines.
Oh, we love a human in the loop.
We do. But the data pouring out of pipelines like this strongly suggests that our own intuition might soon be the least reliable metric in the entire workflow.
Something to definitely chew on the next time you ask an AI to summarize a massive document for you and wonder who is really checking the work. Thank you so much for joining us on this technical deep dive into the architecture of trust. We love pulling apart these complex systems, getting into the mechanics, and sharing the aha moments with you. Until next time, keep questioning, keep learning, and we'll catch you on the next deep dive.